This segment looks at 3 examples of type checking in a polymorphic context. Let's start off with the function f. F takes 2 elements, x and y, as a pair, and it returns a pair of x paired with a list enumeration that begins with the character a and ends with y. Now, one of the ways of thinking about type checking is thinking about the constraints that are put on the types of values by the definition that's given. And it's pretty clear from this that x is completely unconstrained. X is nothing in here that says anything about x at all. We simply take x as the first half of a pair and return it as the first half of a pair. So let's give that type A, type variable. On the other hand, we're using y in a range for an enumerated type, and the first element of the enumeration is a character. So y must itself be a character. So that tells us that the inputs are, it's a pair of an element of type A and a character, and the result is a pair where the first element is of type A again, and the second is not a character but a list of characters. So we have our function f taking x, y to x and this range of characters. So there's our function f. What about this function g? G takes a pair m and z and returns m plus the length of z. Now, what do we know here? We know that length is a function that takes a list and returns an integer. So length of z must be an integer. And because that is combined with m by a plus, m itself must be an integer. So the type of m must be integer. On the other hand, the type of z's, all we know about that is that it's a list. We don't know anything about the elements. So g is a function which takes a pair which is an integer and a list of b, where b is a type variable, and then returns an integer. So that gives us, we've got our 2 functions now, f and g. Let's define h by composing f and g. So f takes a and a character and returns a pair of a and a list of char. On the other hand, g takes an integer and a list of b and returns an integer. So what we need to do here, if this definition is possible, the input type of g has to match the output type of f. Now, we now understand that doesn't mean that they have to be equal. It means that we have to be able to unify those two. We have to unify the output type of f, which is a paired with list of char, and the input type of g, which is int paired with the list of b. And we can unify by taking a to int and b to char, and so we get these particular types for g and f. F taking an int and a char to int paired with a list of char, and g taking an int and a list of char to an int. And we can see that now we're able to see that the overall type of h is from int and char to int.